Hey guys, this is going to be the first video for the second semester, and it's on proportions. Unfortunately, I'm battling COVID right now on about day 4, and so I won't be at school tomorrow, but this at least will give you an idea of how to fill out your documents, and I'm going to get you on going on the notes. Now, what I'm going to do also is I'm going to start creating a playlist for the semester so you guys can follow these more easily. So let me get to it. I apologize for the intermittent coughing, COVID fun. So what you can see on the screen is this is going to be the notes packet that you're going to have, and I'm going to give this to you guys. Y'all will have a copy. And I want you guys to start keeping a journal or keeping a notebook. And so I'm going to require a notebook. You're going to need to bring one to class. So we have ratios. Okay, so when we're looking here at ratios, sorry, I'm going to erase that. That's annoying me. A ratio is a comparison of two numbers by division, and we see ratios in a multitude of ways. And when you look at ratios can be seen pretty much everywhere. Anytime you have a fraction, it's ratio. A ratio, you're basically just comparing two values, which is what a fraction is doing. You actually will see fractions and ratios everywhere. And here are some common examples I'm going to show you. Let me pull up some of these pictures. So if you guys have ever collected any kind of cards, baseball cards, Pokemon cards, Dungeons and Dragons, anything, you'll see these written on the back of the packages. Now, what these are actually ratios. And what these tell you is what are your chances of actually pulling one of these special cards. Now, if you're not familiar with card collecting, in card collecting, you buy packs of cards. Let's say you're buying baseball cards. Well, every card, there's a regular set of cards, which is the most common, and then there's special cards. They might be shinier, they may have maybe a piece of someone's real jersey, or they might just be what they call a parallel card, where there's foil stamping and extra materials on there, and it's a glossier and worth a lot more money. And so you usually get these. You see rainbow foil, vintage, Independence Day, Mother's Day hot pink special, Father's Day powder blue. So these are sets that you'll find within the regular set that are very hard to find. If you look at the odds here, which is a ratio, of pulling the gold card, 1 out of every 13 packs had a gold card. So if you bought 13 packages of these baseball cards, chances are you would get 1 gold card. In 2020, it was 1 in 14. You had to buy 14 packages to have a chance of possibly pulling 1 gold card, and then 1 in 27. Another place that you'll see this is McDonald's. 1 in 4 chances wins. So what that means is you've got a 1 in 4 chance of winning. So out of every 4 meals you buy at McDonald's, one of them is going to be a winner on average. That doesn't always happen. It doesn't mean that if you go to McDonald's 4 times, you're going to get 1 winner, because the way it works is when they produce all of those cups and fry boxes and everything on the assembly line, every 4th one is stamped a winner, and then they shuffle them. So you're not going to necessarily get it, but that's the odds of winning. Chances are, if you go 4 times, you're probably going to win once. And so that's how they use those ratios. So anyway, let's go back to the original document. And that's when you see it written right here with the colon. And this also has a different purpose, but for right now, we're just going to focus on the fraction. A proportion is 2 ratios that are equal. And what I want to show you here is you've used this before when we reduce fractions. Here are 2 equal ratios. 1/2 is equal to 2/4. Those are the same ratio. They're written in different formats, but they are the same ratio. If I wanted to keep going and I wanted to do another one, and I don't think it's going to write me right off the page, what about 5 out of 10? 5 out of 10 is also a ratio that is equal to 1/2 and 2/4. So you can have 2 ratios that are equal that are written in different formats. If 5 out of every 10 people likes the New York Yankees, that means that 2 out of every 4 people probably like the New York Yankees, or 1 out of every 2 people probably likes the New York Yankees. So that's what equal ratios are. Down here, if 2 ratios are equal, then the cross products will be equal. So if I set two fractions equal to each other and I cross multiply, those products are also going to be equal. So let's examine this piece up here. Let's just take a snapshot. Let's look at these two guys right here. If those two fractions, those two ratios, are actually equal, when I cross multiply them, I'm going to get two equal numbers. So let's cross multiply. What's 2 times 2? That's 4. What's 4 times 1? That's 4. Therefore, those two fractions are equal. And it works. What if I just wanted to isolate these two? Now let's do this one. What's 10 times 1? 10. What's 2 times 5? 10. Those two fractions, those two ratios are equal. So when I look at this particular example, remember, don't get confused when you see letters. Letters, guys, are variables. They're just placeholders for regular numbers. So let's cross multiply these guys just like I would any other fraction. B times C is BC. Remember, that's how we write it. And A times D is AD. So anytime you have two fractions, or you have two equal ratios, when you cross multiply them, you're going to get an equal value on each side. So for the next example, and I'm going to do a couple of these examples for you. Let me go ahead and scroll up here. So determine whether each pair of ratios forms a proportion. So if I can make a proportion, that means my two ratios, my two fractions, I'm going to keep repeating that until you get sick of it, are equal. So what I'm going to do is I'm going to set these up, and I'm going to test them, and I'm going to see, are they in fact equal? So let's take 4 over 6 and set it equal to 12 over 16. And let's try cross multiplying. Now, there is a shorter way. If you feel so inclined to do so, you can actually reduce these fractions before you cross multiply them to give you smaller numbers to compare. Now, does it mean that you're going to get a different answer? No, they will either still be equal or they won't be. But I'll show you the reducing in a minute. So let's just do it without the reducing. I'm going to take 6 times 12, and when I multiply 6 times 12, I'm going to get 72. And then I'm going to take 4 times 16, which is 40, and 6, which is 64. Now, are 72 and 64 equal values? No, they are not equal, which means this is not a proportion. Those two are not the same. If you want to see the reducing, to see how that works, let's reduce these. 4 over 6, and let me use my cursor here. 4 over 6 I can actually reduce to 2 over 3, right? And 12 over 16, that can actually reduce to 3/4. Now, you should be able to tell that that's as far as you can reduce these. These are not reducible fractions anymore. They're irreducible. It's as far as you can go. But if I cross multiply them, I'm going to get the same result. 3 times 3 is 9, and 2 times 4 is 8. They are not equal. So if you want to reduce them first, you can. Sometimes when you reduce them first, you actually don't have to cross multiply. Case in point, the very next example. If I take 3 over 5 and I do the reducing first, 3 over 5, can I reduce 6 over 10? I actually can. 2 goes into 6 3 times. 2 goes into 10 5 times. I don't have to cross multiply. My answer is yes. This is a proportion. They're equal. But let's say you're having trouble reducing. Well, let's just set up our equation, 3 over 5, 6 over 10, and let's see if that is actually possible. By the way, I'm going to go back and do this because that's the proper way to do it. Those were not equal, so I'm going to slash through the equal sign. So let's test these guys out. 6 times 5 is 30. 3 times 10 is 30. Yes, we have a match. So you can see this is how you actually compare and see if they're equal. Now, On A and B, you were not given equal signs, right? You were not given equal signs on A and B. But on 2 and 3 down here, you are given equal signs, so they are telling you already these are equal. Let's solve them, and let's see what we can get when we solve. I'm going to look at example 2, and you will need a calculator for this because you've got decimals, but let's go ahead and let's do our cross multiplication. Well, 4 times A, again, we're seeing that they're equal. They're telling you up front that there's an equal sign. Notice up here, it's asking you, should the equal sign be able to be placed? And we figured out no on this one, yes on this one. Down here, the equal sign is already there, so it's telling you they're already equal. So we know they're already equal. 4 times A is 4A. And then I've got 7.8 times 3.82. And I'm actually going to turn on my calculator and figure this one out because I don't feel like doing mental math right now. So 7.8 times 3.82. And I'm sorry, let me go to my scratch pad here. There we go. 7.8 times 3.82. And we get 29.796. Now I know those values are equal because it tells me they're equal already. There's already an equal sign. I keep repeating myself, but I want you to understand it. Now we've got a simple algebra equation to solve. So I'm going to actually solve for A. Remember, A is our variable. I'm going to divide both sides by 4. So when I use my calculator and I take 29.796 and I divide it by 4, I end up getting 7.449. So that is your answer. A is 7.449. Now, I'm not going to have you round right now and worry about significant figures. It will tell you round to the nearest tenth, round to the nearest hundredth when you solve your problems. We don't get into significant figures like you do in chemistry, so in science, so don't worry about that right now. Okay, let's check the next one. I'm going to cross multiply. Now, before I do that, what do you see here that makes things a little different? I'm going to try to zoom in. I don't know if it'll let me. There we go. I've got this negative sign here, guys. So the question is, where does that negative sign go? I can either put that negative with the 3 on top, or I can put it with the 7, but not both. So let's put the negative, I always put the negative with the top number, so I'm going to rewrite this as negative 3 over 7 equals x plus 2 over x. Okay, so now I'm going to follow my cross multiplication. I know they're equal, so 7 times x plus 2 looks like this. Okay, and remember the equal sign comes down, and negative 3 times x looks like this. Okay. So again, I'm cross multiplying. Now I'm going to move my document up so you can see a little bit better. I've got to follow my algebra and order of operations. This is where you're really going to have to get good at your distributive property and your algebra skills. A lot of people make the mistake of when they multiply this term times this term, they just multiply the 7 times the x and then just leave the 2 a 2. That 7 is being multiplied by the whole thing. In fact, what I do when I see proportions like this, the first thing I do when I see fractions is I put parentheses around by polynomials, terms that have expressions that have more than one term. That way I know when I multiply it out, I'm going to have parentheses, okay? So I've got the negative 3x, and now I'm going to distribute. So 7 times x is 7x, and 7 times 2, sorry, my pen disappeared here. Oh, it looks like my program froze. And I fixed it back up. So then we've got 7 times 2, which is 14. And again, we're following, if you want to draw your line, you can. We're following our algebra course of action. And so we want to get all of the variables together and all the numbers together. So I want to get that 7x over. So since that's a positive 7x, I'm going to subtract it to move it to the other side. And that's going to give me a negative 10x on this side. and that's going to give me a 14 on this side. So when I get to this point, I'm at the last step. Again, I'm solving for algebra. I want to divide both sides by what's in front of my variable. So I'm going to divide both sides by -10. Now, what this does, -10 divided by -10, if you look at the highlight here, this gives me 1, because anything divided by itself is 1. Guys, this is why we do this in algebra equations. When I divide something by itself, it becomes 1, hence my 1x over here. And that's what I'm looking for. What is 1x worth? I don't want to know what -10x's are worth. I want to know what 1x is worth. So 14 divided by -10, you can write this as a fraction or decimal. When you reduce this, it's going to be negative because I have a positive 14 divided by a negative. So I'm going to have a negative answer. So that's going to be -7/5. Now, if you want to actually put this in your calculator and get the decimal answer, you can do that. So I'm going to do -7 divided by 5. And I get -2 point, whoops, sorry, my calculator divided the wrong thing. So -7 divided by 5, and I get -1.4. So that could be also -1.4. So this is how you do the proportions and how you solve proportions.